Hey guys, what's going on? Welcome to your very first tutorial on computer security concepts and cryptography. So this is my very first online tutorial, so if I get anything wrong or you have any suggestions, please don't hesitate to post a comment or send me an email. So how I'm going to do this is I'm going to break it up into a playlist, so maybe 10 to 15 minute long videos. I'll break it up so you can skip through and you can find the topics that are relevant to you and what you want to learn. So in this video, we'll start off with the definition of cryptography. So the definition of cryptography, it is the practice and study of techniques for secure communications. So it's constructing, it's analyzing protocols that prevent third parties or the public from reading your private data. So there are three key objectives that are within network security or cryptography as well. So the first one is confidentiality. The second one is integrity. Yes, I know I can't write or spell. And lastly, availability. Okay. So there are two. We can break up confidentiality into two. So first off, we can talk about the data confidentiality. So we can talk about, assuring your data is not seen by people who you don't allow, and privacy, which we all know what that is. So privacy, it's basically the process of an individual or entity choosing to disclose whatever information they choose. So integrity can be broken up into two as well. One is data and one is system. So data can be, data integrity can basically, it ensures that your data is not being manipulated by an unauthorized entity or an individual. Whereas system integrity actually allows a system to perform in its intended manner without unauthorized manipulation. Lastly, we have availability, and that assures that everything works and is not denied to authorized users. So we don't have to go too far into that one. We all pretty much know what availability means. Okay, so just clear this screen. Alrighty. So within network security within network security, there are two types of attacks, right? So we can break them up. So we have two categories, passive and active. Okay. So passive attacks, they're more in the realm of eavesdropping and monitoring passing or transmitted data. So there are two types of passive attacks. The first one is release of message contents. So it's more things like telephone conversations, emails, and a transferred file that may be sensitive or contain confidential data. So passive attacks are very difficult to detect as they do not manipulate or change data. The goal is to listen, and just listen for sensitive information. All right? So the second category is traffic analysis. So this one here, it doesn't have anything to do with unencrypting the sensitive information and finding out what they're talking about, right? It's more about capturing the encrypted data and coming up with patterns and seeing who's talking to who. So it's more in the nature of just finding out finding the communications between two entities. So who's talking to who, what, yeah. So like I said, with passive attacks, they're very difficult to detect and they do not manipulate or change data. The goal is just to listen for sensitive information. So within the realm of with active attacks, right, it's the modification to the stream or can even create a false stream of data. So active attacks are more of what we hear about that cause damage, right? They all cause damage, even passive attacks, they all cause damage. But active attacks are active tags, they modify the stream of data. Right? Sorry, that took me a while to get out. So first what we have, I always cannot spell this word, masquerade. So masquerade, it's when someone pretends to be someone else. So A and B are talking, I intercept a message between A and B, I am C, and I am pretending to be A, talking to B. That's masquerade. The second one in active is we have replay. So replay is it's the passive capture and retransmission of data to produce an unauthorized effect, so to gain access to something. So it's similar to masquerade, but yeah. The third, modification of data. Modification of data. So this simply means that some portion of the message sent is modified, a message is captured, modified, and then resent to produce a malicious or unauthorized effect. And lastly, we have a DOS. So DOS stands for denial of service. And if you're studying computer science or computer engineering, you'd probably know exactly what this is. So I can just go over it really quickly, but it's basically prevents the normal use of infrastructure by either overloading a system or inhibiting its use by other means. So slamming it with junk traffic until it crashes. So cryptography is absolutely everywhere. So a few examples of, let's get a nice, like a light blue here. So as I said, it's absolutely everywhere. So it's within your web traffic. So it's within your browser, HTTPS. We'll talk about that later. It's in your wireless traffic, so your 802.11i, I think it is, in your WPA2, in your WEP, so what your router transmits. It's in your GSM as well. For mobile communications, it's in Bluetooth, it's in absolutely everything. So it's also, like, for example, the simplest way I can put it is imagine a user, right? So a user, I'll change my color here, is creating a password on a web server. These are my web servers, by the way, and it can match a store password. The user can send a password, say, "Hey, I'm this person," and check on the server for a hash that matches the password. So we'll talk about hash functions later, but that's a general use case of cryptography, is password hashing and password storing. Because obviously, if passwords get out, then all of your information is accessed by whoever has your password, which is very, very, very bad. Okay, so there's a few definitions that you need to know when it comes to cryptography. So you have plain text, which is your unencrypted plain text, your ciphertext, which is, So that is your text that has been encrypted. You also have your encryption and decryption algorithm. And then you have your cryptography. So cryptography, again, like we said before, was the area of study for many schemes used for encryption. So another one as well is that you'll probably hear a fair bit is cryptanalysis. So cryptanalysis is a good one. So it's the technique used for deciphering a message without any knowledge of the original encryption process. So for example, studying a certain algorithm to find flaws in order to crack the code pretty much. So this is a basic example of encryption in communications. Okay, so let's say we have, let's just use the old classic examples, hey? So this one goes to here, to here, to here, to here. Okay, let's call this Bob. And this can be the transmission medium or the satellite station or whatever. This is the satellite. So first off, we get a message, right? Whoops. Let's change the color here. We get message M, okay? So when you use Alice's secret key, called K, right? Which is then encrypted with the encryption algorithm, okay? So now we get E with the key of Alice and the message equals C, right? Which is the ciphertext, okay? So we also get C, that gets, C, that comes through the transmission medium. So here's the ciphertext, right? And then we have either the cipher key or the secret key for that Alice and Bob share with the decryption process gives us DKC, which is equal to M, run out of space here, right? So this is the general, very, very simplified version of how an encryption works. So this here would be an example of a symmetric cipher, and we'll get through that later. It's not a public key, right? Alice doesn't have a private key, Bob doesn't have a private key. Only they share one secret key. So that is what we call a symmetric cipher. So first off, we can talk about the types. Whoops, I don't know why it does that. The types of encryption used. So we have, why is it doing that? So we have substitution, and we also have transposition. Okay, so for example, the encryption algorithm replaces. So when it comes to substitution and transposition, all you have to remember is that you have an encryption algorithm that can replace the characters, right? Which is the substitution cipher, or an encryption algorithm that rearranges the plain text, which is a transposition cipher. Right, so that's the only two difference between this. This one replaces with something else, so A can turn into C, whereas transposition, change my color here, transposition is, let's say you've got like A, B, and C, and the transition turns it into A, C, or B, C, A. So it just, switches it around, right? So we also have the number of keys used. So we have symmetric and we have asymmetric. So asymmetric has one key. That is it. And this is usually known as the secret key. So asymmetric is good for, if you and your friend just know the secret key and you know that no one else is going to compromise that and no one else is going to know the secret key. That is fine. Whereas asymmetric, we actually have two, and it's called a public key crypto system. So that's what we use that type of encryption for. So we have a private key, and also a public key. Oops. So just to run over that again, so symmetric is a single key encryption where you can conceal data of any size, while asymmetric encryption is where you have more than one key and you can conceal small blocks of data. So asymmetric is, like I said, its encryption is usually used for the purpose of digital signatures, because encrypting large amounts of data with it just takes too much time and it's just too much effort. So lastly, I'm just going to quickly talk about how the different types of ways that the plain text can be processed. How the plain text is processed. Sorry for my terrible handwriting. Okay, so first off, we have what is called a block cipher. So a block cipher is encrypts and it decrypts blocks of text one block at a time. And secondly, we have a stream cipher. So stream cipher, it encrypts and decrypts the text by taking 1 byte of text at a time. So blocks of text at a time and 1 byte at a time. That's all you got to remember. Alright, so that wraps up the first tutorial, guys. Make sure you check out the next one where I discuss symmetric ciphers.